This is page 1 of the chapter 4 review. So, the first problem says the graph, the first problem, I guess the 0th problem, is about investment. $11,000 invested in an account earning 4% interest compounded monthly. So let's think about that. The principal amount, she's starting off with $11,000. The interest, the rate, is 4%. That's 0.04. The number of times compounded, she's compounding it monthly. That's 12 times a year. And the time equals 7 years. Now the formula for compounding interest is that the amount that you have is equal to the amount you start with, the principal amount, times 1 plus the rate. Oh wait, we've got to compound this. So the rate divided by the number of times compounded, all to the power of number of times compounded times time. What this comes out to in this problem is 11,000 times 1 plus 0.04 over 12 to the power of 12 times 7. If you put that into your calculator, I'm going to do this with a fairly basic calculator. Oh, I don't think I'll be able to do this with this calculator. I will. 0.04. That's not right. 0.04 divided by 12 times plus that 1 gets me this number, all to the power of 12 times 7. Well, that is 12 times 5 is 60, plus another 24 is 82. Gets me 1.31, all that times 11,000. By the end I will have $14,451.15. And that's all there is to it. The key here is being able to say what your variables are, remember the formula, and just plug it in. Now, let's take a look at the second problem. We've got a graph of f of x, and we need to graph its inverse and h of x. But first, is this function one-to-one? Well, to test if something's one-to-one, you can draw the vertical or the horizontal line test. The vertical line test sees if it's a function. The horizontal line test sees if it is one-to-one. Since two different inputs have the same output, this function is not going to be one-to-one, which means when I graph its inverse, I'm going to come up with something that is not a function. But I can still do that. Let's talk about these points. This point over here is at 6, -4, so I'll swap that and put it down here. Plot the point -4, 6. This point here is at 2, 2, so I'll swap that. Oh wait, it's still 2, 2. Over here I've got the point -5, 2, so I'll swap the inputs and the outputs. Graph the point 2, -5. And the last point is at -9, 0, so I'll swap those and plot the point at 0, -9. This line right here is the inverse of f of x. Well, not a function, but it does show up. The second problem is taking our functions, going to this x minus 4 says write 4 units, The negative says flip vertically, and the 2 says stretch vertically by a factor of 2. So, 3 things that are happening to these numbers. And I can take the point, 6 negative 4, over 6 down 4. I can shift it to the right 4 units, 1, 2, 3, 4. Flip it vertically, now it's up at positive 4. And stretch by a factor of 2, bringing it up to 8. There's my first point. The next point at 2, 2. I shift it to the right 4 units. I flip it vertically to put it at negative 2 and stretch it by a factor of 2, putting it down to negative 4. The third point, negative 5, 2. Back 5, up 2, shift to the right 4 units, flip it vertically, and stretch by a factor of 2. The last point at negative 9, 0. I like that one because vertical flips and stretches don't do anything, and I can just shift to the right 4 units. If I flip 0 vertically, nothing happens. If I stretch from 0, it is still at 0. This is going to be the graph of my function. You can take a look at the original function, see that it's now flipped over, and see it's shifted to the right and stretched out and maintaining its general shape and size. This has been the first page of Chapter 4. Hope that you found it helpful, and feel free to check out the second page.